Well, that animation was probably cooler than my talk, so good place to start. But welcome everyone. Thanks for coming here, especially thanks for coming to a security talk. I know that these can be depressing, and hopefully we'll be able to to move through that together. But we're going to talk about supply chain attacks. We're going to look at supply chain attacks from the inside, how they work, why they're so predominant at the moment. And to do that, we'll break down a bunch of different attacks in different styles. So some are more traditional and fit in with what you would think a supply chain attack is. And also some will be a little bit kind of on the fringes, but I'll explain why I believe these fit into the categories as well. So a little bit about me. So I'm from pretty far away. I'm from Aotearoa, which is also known as New Zealand. But today I live in the Netherlands, and I work for a French company called GetGuardian in Paris. You can find me anywhere on social media. I also am the host of a security podcast called The Security Repo. My mum says it's her favorite podcast, so you should definitely all check it out. It'd be great to have at least 3 people listening to it. But we have lots of fun guests on there and hackers, and we break down exploits on that. So in today's talk, as I just said, we're going to be talking about supply chain attacks. So at the start, I'm just going to talk about what is the supply chain and what are supply chain attacks. And then we're going to look at how we can target as adversaries different components of it. So we'll talk about attacking dependencies, attacking the source code, and attacking the build process. And then finally, once we're all thoroughly depressed with that, then we'll talk about how we can actually solve this problem. And then I'll be available for questions if anyone has any too. Just nothing too hard, please. Okay, so what is a supply chain? So we probably am aware with what we talk with a supply chain, even if you're not aware of the software supply chain, works in a very similar way. So we're probably familiar with a normal supply chain. For instance, if we're building cars, we have raw components and materials, we have assembly lines, we have testing stations, and then we ship it off to the end consumer. So software is no different. We have our open source kind of code and proprietary code. We have our dependencies in there. We have our equivalent of assembly lines, our IDEs, which we actually use to put everything together. We have continuous integration and testing like Circle CI, Jenkins, other areas. And then we have our artifacts at the end, maybe a Docker image or something else, right? So this is really what the supply chain is. But in software, it can get really quite complicated because there's lots of different tools. Different teams use different tools. They're interconnected with each other. And they can kind of be very, very hard to map out exactly what our supply chain is. And I'll talk, we'll go through a little bit more about why this is so complicated throughout the presentation. All right, so now that we've caught up what supply chains are, let's talk about supply chain attacks. So supply chain attacks have really changed the economics that adversaries use. So we talk about hackernomics for a minute, where a lot of people are still stuck in this mentality that an attacker, an adversary, is some kind of lone wolf operator in their mum's basement with a hoodie on, working on computers. Now, more and more, that is absolutely not the case. So the adversaries that I'm really focusing on in this talk are more like organizations. They run like businesses. They have employees. These employees have sick days. These employees have holidays. They have operating expenses. And they work on a model of risk and reward, just like any other ordinary business would. So if this adversary, this organization is targeting someone, they're targeting a victim, then a lot of equations go into that, in that whole risk-reward process. If that target turns out to be too difficult to an attack, then they simply just move on. But the reason why supply chain attacks changed all this so much is because now if we target a component in the supply chain that multiple organizations are going after, then all of a sudden we can attack hundreds or not thousands of organizations, including the ones that were previously too hard. So organizations, like the US defense have been compromised by supply chain attacks, whereas targeting them individually probably would have been too difficult. And this means that we can really invest huge amounts of money into these exploits. So now the economics have changed. So these organizations that were targeting individuals not so long ago are now targeting components of the supply chain. And what we're seeing as a result of that is that these are getting more and more sophisticated. There's more and more organization going on into this. They're lasting for a lot longer, and they're getting harder to detect. So it's all comes together with probably not the greatest of calculations, but that is essentially why supply chain attacks are so common on the rise and why they can have such severe consequences. All right, so let's talk about the supply chain in a little bit more of a simplistic way. So this here is an image that's put together by Salsa, which is funded by Google, talking about basically visualizing the supply chain. And we're probably familiar with this. We have a developer, we have our source, like our source code, we have our build process. Tied into that, we have a lot of dependencies, open source dependencies, third parties. And then at the end, our package is made and it ships off to our consumer. Now this is obviously very simplified, but it helps us understand what we're talking about throughout when we're discussing the supply chain. Now every part of this is vulnerable and susceptible to a supply chain attack. There is no part of it that isn't at least susceptible. There is no part that has no risk associated with it. The build process at the moment is probably the hottest, where you're targeting your CI/CD pipelines and other areas like that. But we'll talk a lot about a lot of these, and what we're going to focus on is really just the source code, the build, and the dependencies. So we'll get started by taking a look just at dependencies, because this is probably one that might be familiar to a lot of people. So software dependencies, we probably know what they are, and the one that we're most familiar with is our open source dependencies. We have our application. Our application needs to do lots and lots of things, but only if a little portion of it is unique, right? We need to authenticate ourselves with our applications. Everyone needs to do that. So we use open source tools or other areas to do all the parts that isn't unique to us. The problem is that these open source tools also have dependencies. So our open source dependencies also have dependencies. They have dependencies, and we can extrapolate this in the most extreme cases to about 30 levels. Not all of them do, but this makes it really, really hard to be able to even understand what you're vulnerable or what your software is using. And then on the other side of that, we have our third-party services. Now, these are dependencies as well. So we might be using Stripe as a payment system. We might be using Cloudinary to kind of store data. So these are part of our dependencies in our application as well. Now, right now, this looks very neat. We have our open source on one side. We have our third-party on the other side. I can see the layers. It all makes sense. The reality looks a bit different. The reality more looks like this. And that's because our dependencies are dependent on each other. Our third-party tools are dependent on other dependencies. And what this means is that if something is turned malicious way down the chain, for instance, let's just call this box log4j or log4shell. And once that can happen, then a whole series of events can be turned malicious, and that can turn your application malicious. But the problem is that we really don't have good understanding right now about what is our application even made up of, and exactly how much risk we have to events when they happen. So 95% of our code is in our own. This is a number that gets thrown around a lot. There's different versions of it. Some say 80, some say 95. I picked 95 because it's the biggest and it seems more dramatic. But you get the idea that lots of our source code isn't really our own. And most of it, the vast majority of it, is built up of these packages, which actually means that in a lot of cases, the adversaries that are targeting you understand your software and vulnerabilities better than you do. And we trust these dependencies more than our own. We have something that we kind of call dependency bias, where we understand that we probably have bad practices as developers. Maybe in an organization, we're doing some things that we know we shouldn't really do, but we do it. And then we assume that no one else does that and that everyone else is doing everything perfectly, which isn't the case. But we kind of assume that it is, because if we started being suspicious of everything, then, well, we would never move anywhere. So I hate that I have to share this next slide, but I do. So this is the most shared security meme in 2021. It's displayed in every single security conference and everyone, but it explains the state of our dependencies so well. You have our modern infrastructure, and then way down the bottom you have some project a random person in Nebraska has been thanklessly maintaining since 2003. And if that falls over, the whole show falls over. So what I want to do is I want to look at that person in Nebraska that's been thanklessly maintaining something and what actually happens and how an adversary will turn that malicious. So here is an example of something on Node, on NPM. It's a UA parser, and it's a JavaScript library to detect your browser, your operating system, what you're using. So it does a very specific job. It's nothing too exciting, and lots of stuff use it. So if you wanted to be able to detect what browsers you're using in your applications, this might be something you would pick. And when you pick dependencies, there's probably a series of things that you would do before you accepted something blindly into your infrastructure, right? So you might look at the weekly downloads. Here we've got 10 million, so it's pretty legit. We've got 56 versions, so it's not something that's been made once. This is actively being maintained. And there's over 1,600 other tools that are dependent on this. So I don't think there's anyone that would look at this and be like, oh no, this isn't legit. This is about as legit as it comes. And this is the guy that's been thanklessly maintaining it for years, Vishal Salman. Now, we like Vishal. We're not here to be negative to Vishal at all, but he represents millions, hundreds of thousands of open source maintainers out there in the world. They have other jobs. They're maintaining this. It requires effort. But this isn't all that they're concerned of. There's a very small people that get to work on open source full time, but most people don't. And most people just kind of thanklessly maintain something. And this guy has something that gets tens of millions of weekly downloads, and that's his responsibility. So what ended up happening with UA parser? So on a Russian forum, this appeared, which said, "Hey, I'm selling an account on NPM. It has 7 million installations. There's no 2FA on the account, and here's some things that I should do." And it's basically, we're going to start bidding at $10,000 in $1,000 steps, or you can buy it for $20,000. So this is basically selling an NPM account. Now, I'm sure you've probably figured out whose account they're actually selling, but through a phishing campaign, they managed to get into Vishal's account, and from there, they took control over it and turned it malicious. So what did they do? They put some credential stealers and a crypto miner in there. So the credential stealers was trying to steal credentials specifically from Windows environments, and the crypto was kind of, hey, I got to make my money back, so let's do this. And a couple of lines. It took a while before anyone even noticed that this was here, and then finally when Vishal noticed, he was locked out of his account. Now, luckily, eventually he managed to get it back. But today, there are still people using the malicious version of this package, and this happened quite some time ago, about almost 2 years ago. So this is an example of how a dependency can be turned malicious in a supply chain account, and no one's done really anything wrong. We could argue that Vishal should have had 2FA on his account, and now on that would be mandated. But I mean, this is the situation that we're in when it comes to open source dependencies, and things can get even more kind of extrapolated. Here's another example called Event Stream. Again, this is on NPM. Again, it passes all the smell tests of everything that's happening. And what ended up happening with this? Well, a lot of open source tools are set up in a way that if you start maintaining it regularly, then you'll get core maintainer access to it. You'll be able to automatically move through the steps. So that's what happened. Along came a good Samaritan, and Event Stream stopped being regularly maintained because the people that created it needed it originally for their project, and then they stopped needing it. Then they didn't need it anymore, so they stopped maintaining it regularly. Good Samaritan comes along and says, I'll help you maintain this. He got core maintainer status. He was able to control it. And what he did is he actually didn't turn Event Stream malicious. He added another dependency into it. He added something in there called Flat Map Stream. And originally Flat Map Stream wasn't malicious, but it was added in there for the entire purpose of becoming malicious. So this is a downstream event that, again, was able to turn lots of things malicious and use your computational power, again, for crypto mining and other things that happened downstream. So these are just a few examples of what can actually happen when we're talking about our dependencies and how they can be turned malicious. So it doesn't even need to be the fact that the dependency is malicious to start with. It can be the fact that someone just takes it over and goes ahead and turns it malicious. So what I want to talk about now is I want to talk about the source. I want to move away from our dependencies, and I want to talk about how our source and our source code is kind of targeted in supply chain attacks. Now, this is kind of interesting because the source code is directly targeted, and the tools that we use to host it are, but also source code is often a target of different supply chain attacks. So source code is absolutely everywhere. You may think your source code is private. I just kind of call it not so open because it ends up distributed everywhere. It's on all your developers' machines. It's backed up into wikis. It can be backed up into different areas. It's literally extremely easy to access, but it also can be very sensitive. Not from an IP perspective, because there could be secrets in there, particularly in its history. There could be business logic flaws that it's letting up. So there could be lots of things that your source code can contain. And you probably know this site. Now, this is kind of a little bit of an obscure example. Now, I want to bring up this because I want to show you how things you don't even realize can be part of your supply chain but are. So this is GitHub, the world's most popular open source platform. I'm sure everyone's familiar with it. It has about 100 million developers as of right now that are using it. And what's interesting about GitHub is that even if you're not using it as an organization, it's not part of your supply chain, your developers are using it because they need it for their portfolios. Maybe they're maintaining open source things. Perhaps they're using it on their personal projects. So GitHub is something, and the way that it's been set up as a social platform as well means that you can't really afford not to consider GitHub as part of your supply chain. And GitHub is an interesting example because here we can have kind of a supply chain attack that uses GitHub, but it's not really attacking it, it's more of abusing it. So just to get an idea of the scale of GitHub, last year there was over 1 billion commits made publicly. I'm just talking about public information. So 1 billion commits made publicly, 85 million new repositories, 94 million developers according to GitHub. So absolutely massive. And in this case, I want to do a quick demo of not so much a supply chain attack, but a supply chain abuse. Because in this case, an attack insinuates that I'm trying to get malicious access into something. I'm trying to break into something, and I'm going to use that for malicious purposes. But an abuse could be, I'm using this in the correct way that it's designed to be used, but I'm just abusing it for malicious purposes. So I have a very quick demo that I want to do really quickly to show how attackers are using this. So if you notice on my screen here, I have some AWS credentials. No one take a picture. No, I'm kidding. So these are honey tokens. And what I'm going to do is I'm going to put these in a public repository in GitHub. This is the number one sin that you could do ever. Now, there's so much secrets in GitHub. It's insane. But what we're going to do is we're going to commit this now. And then down here, we're going to monitor in a few minutes how many people have tried to exploit those secrets. And this is an example of a supply chain abuse where people are abusing the GitHub API to try and find secrets that's part of your supply chain, even if you're not aware of it, to basically gain access into you, because that's what this is all about. It's about gaining access into your infrastructure. So every year, the company that I work for, GitGuardian, we release a report called the State of Secrets for All 2023. And one of the things we do in this is that we monitor public GitHub for credentials. And we check that they're valid, and we validate them, and then we republish our thoughts. Anyone here have any idea how many secrets we would have found last year in public repositories in GitHub? Thousands? Who thinks more than 100,000? Who thinks more than 1 million? More than 5 million? We found 10 million. So we found 10 million secrets that have been accidentally published in GitHub. Now, why does this happen? There's lots of reasons. I'm not going to go into detail into this talk about it, but basically, they can be in your history. Buried in your history, you accidentally commit something, and that whole history comes along with it. You can imagine a scenario developer working on a dev branch, hard codes credentials, removes them, still in the history. And then it gets made public. Those types of scenarios. You could be adding log files that contain environment variable dumps, lots of different things. Some of the secrets that we found, about 25% were for data storage, 20% were for cloud providers, so that's about 2 million cloud provider keys. Cloud providers particularly, we validate them. So I'm not talking about random high entropy strings that could be test credentials. These are actual credentials that give access to something. So why is this all relevant in the course of supply chains? Well, this is why attackers are really targeting your systems like GitHub and other areas in your supply chain, because they can find sensitive information about you. And as an attacker, I can also do lots of malicious things through GitHub, like I can monitor just your employees once I know that they're there. And if they do anything, like they leak corporate code, then we can find that. So how does this all happen? How do we abuse GitHub? It's very easy. So there is a public API, a public events API. So we can all just go to it. I can show you it. Oh, whoa, I skipped all the way to the back. I didn't even know that was possible. I have too many slides. All right, this here is the GitHub API. Anyone can access this. You don't even need authentication. And this is a public ledger of everything that's happening on GitHub in real time. Well, it's not quite real time, but you can capture everything that happens in GitHub. So this is what attackers will absolutely be doing. There's a bunch of events that happen in here, but the two that are interesting are the public event and the push event. So public's the most interesting. It's when a private repository goes public. The reason it's the most interesting is because in that case, all the history's gone public with it. So if you have nasty things in the history, like secrets, then they'll become public with it, with that. So this is how we can abuse part of your supply chain without actually doing anything wrong. We're using everything in the correct way, but we're still targeting your source code and everything that's happening within it. So this does cause real-life breaches, and this one's really interesting. I use this one not because of how bad it was, but because it illustrates how vulnerable we are to it. So Toyota have a mobile application called T-Connect. I believe it can do things like start your car, so it's quite important. And they were building that with a consultant. Now, I don't know if Toyota personally uses GitHub Enterprise or GitHub in their organization. But what ended up happening is outside of Toyota, one of their contractors accidentally leaked this code on GitHub. Inside that code was the database credentials so that threat actors could then access all the users of that mobile application, and they then could launch phishing campaigns against them, specifically targeting them because they know that they have a Toyota, they know lots of information about them, and they can kind of get higher yields. So this is an interesting result, not because of how critical it was. In fact, a lot of people probably haven't even heard of it, but just because it goes to show that even if GitHub wasn't in Toyota's supply chain, it can still be targeted by threat actors by abusing it in different ways. Now, the other thing I like to talk about, just when it comes to source code, is that source code is never as private as you think. Cyber News, which is a cool organization, they did some large-scale domain scanning to see how many .git directories were publicly available and publicly exposed, and they found 2 million of them, and lots of them had secrets within them. So this is when you think that your source code is private, but actually, just by doing some domain scanning, you can find your source code. And the other area is in what I like to call involuntarily open sourced. And there's lots of examples of companies that have this source involuntarily open sourced. So Lapsus went on a rampage last year, and they published Microsoft, NVIDIA. Twitch's source code got published because they had a misconfiguration. So we can't rely on that source code component of our supply chain actually being that secure. And we can find lots and lots of sensitive information in there. I'll just give you one example. before we get back closer to more supply chain-y stuff. We scanned Twitch's source code when it was exposed. They had 6,000 repositories, 3 million documents, so it's quite a lot of information, and we found over 6,600 secrets inside that, including 194 AWS tokens. And this isn't that bad. Typically, in fact, it's probably pretty good compared to what we would typically find in an organization. So from all of this, you can understand that there's lots of sensitive information inside your source code, and there's lots of ways that attackers can abuse parts of your supply chain or even attack parts of your supply chain to be able to gain access to it. Okay, so it's been about 10 minutes since I leaked that credential. Let's see how on time the bad guys are today. And so every single one of these, so we've got 10 pings so far. So these are IP addresses. Some of them are the same. So there's obviously the same threat actor publishing it. Now, these aren't people. These are bots that are trying to, basically, they're scanning the GitHub API and they're trying to abuse it. So we have things, we can see what they're using. So TruffleHog is an open source secret scanning tool. And we have lots of interesting results here. So just in 10 minutes, this has been found by 10 people. I was going to say hundreds of people, but 10 people, really, or less than that, about 6 people. And so what's going to happen with that credential? Well, it's really interesting because there's going to be a huge spike of activity today of people basically testing what that credential is. So all of them use the same API call, which was get caller ID, and that's very non-intrusive. It's just testing it. And then what's going to happen is about a couple of weeks from now, it's going to get some more activity, and that's because it's going to be sold in some dark web forums as part of a package of valid credentials. And this is typically what happens when people are trying to gain access into something. All right, so I want to move on from our source, and I want to go on to the build. Now, the reason I did source first is because this is interesting because there's a lot of supply chain attacks that are targeting this build component that are trying to pivot into the source code. The reason is because we just explained why source code is sensitive. It's a very high value target. So by attacking the supply chain, I can potentially get into the source code of thousands of organizations. And there's been lots of examples of where that exact scenario has happened. So let's go through a few of them. So the first one is from 2021. It's a little bit old, but it's very relevant. So this is from CodeCov. So CodeCov, very cool company. I very rarely ever pick on companies that have breaches. They can happen to anyone, really. But what happened here is CodeCov, one of the primary ways you ran it is that you downloaded their Docker image, you plugged it in, and it worked. But a lot of people assume Docker images are these kind of black boxes, but they're just code. You can reverse them. And inside that Docker image was a credential. That credential gave them access to, I believe it was a Google Drive that contained a bash uploader script in it. And that allowed them to edit that bash uploader script to inject malicious code. That malicious code did one thing. So first, where did CodeCov sit? It sat in that build area. When your CI/CD pipeline is building an environment, it needs access to credentials to be able to build it, to access everything. Hopefully, you've got development credentials and production credentials. But you have credentials in there, and they're part of your environment. So what does this malicious line of code do? It said, hey, every time CodeCov run, I want you to dump all the environment variables, and I want you to send them to me, the attacker. So CodeCov, every time that was being used for almost 3 months, was sending credentials to the attackers. At the time, they had 20,000 users that were affected by this. And once it was turned malicious, the attackers were able to pivot into the infrastructure. Now, there's a lot of great companies that were affected by this. Twilio, Monday.com, HashiCorp, Rapid7, and lots more that all had to release breach statements to say that their source code had been accessed and they had secrets in their source code or whatever it was. So there was a lot, and this is an example of how an attacker has been able to pivot from, they've attacked the build pipeline and they've pivoted into your source code. So I like to, just point here, on most of the attacks, all the companies that have been the victims haven't really done anything wrong. It's kind of the intermediary companies that have made the mistakes. It's what makes it so scary. So this here is the one line of code. There was about 1,900 lines of code. Line 525 had this in it here, and then it was all over. So I said that I very rarely pick on companies that have breaches. I'm going to pick on one, but only for a reason, and that is because as part of this, HashiCorp had a breach, and they had to report it. Now, if you don't know what HashiCorp is, HashiCorp builds some fantastic products. I'm a big fan of HashiCorp, and they built a product called Vault. Vault is a secrets manager. The whole purpose of Vault is that they can say, we can effectively manage your secrets. We can dynamically rotate them. You never have to worry about secret sprawl. And they coined that term, secret sprawl, and that you never have to have secrets inside your repositories. So HashiCorp had to report that they had some private keys exposed that were in their repositories as a result of this breach. Now, if HashiCorp have secrets in their source code, no one has any hope. Another kind of similar attack, but a little bit different, is Circle CI. So this one actually happened because there was malware deployed on a developer account, on a developer machine, which was there to steal credentials. It was actually stole a single sign-on session cookie. So sessions are actually can be a lot more sensitive than just straight credentials because they can bypass MFA, which is what happened in this case. They then got access to the encrypted client secrets that were using Circle CI. So if you had Circle CI as a SaaS version, you had your secrets to build the environment stored with Circle CI. The attackers gained access to all of those. They were able to decrypt them based on the privileges that the original developer had. So they were actually able to get the plain text credentials and then again pivot into the infrastructure of the people using it. In both this case and the code cov case, the attackers were really after access into that source code because that's where they knew they could elevate their privileges from. And in this case, it was only discovered because one of the people using Circle CI had discovered that there was some unauthorized access in their GitHub activity, in their private code repositories, and then they basically were just trying to figure out where this came from and asked Circle CI, and Circle CI then went and checked and said, "Oh crap, we might have a problem here." So this is another example of attacking those build pipelines. And again, these targets, the victims, did nothing wrong. They're using reputable tools and potentially could have some massive breaches themselves because of it. So this is just an example of kind of 3 areas, right? Source code, how that is, our build, and also how we can pivot back into source code, and how people are targeting dependencies. And in a lot of these scenarios, in fact most of them, is that the attackers are really able to gain access into lots of different like companies and target lots of different victims. So the consequences can be really wide-reaching for them. So supply chain attacks can feel like a little bit like being a passenger in a car crash. I'm sure we feel like that because it feels right now, and hopefully I haven't depressed you all too much, that this is all just inevitable, that we're all going to be breached and we can't use any open source and that we can't use any third-party providers and we have to go back to punch cards. But it's not the case. We do have more control than we think. I'm just laughing at my stock photography I've put in there. Let's talk about that now. How do we actually get back into the driver's seat? What can we do that actually can protect us? So the first one there that I like to use, and these are some ideas that I have, is to use honeypots. Now, this is kind of changing a mindset a little bit, because a honeypot's not going to prevent a supply chain attack. It's going to let you know when one happens. We need a bit of a mindset shift of not just trying to prevent everything, but also to understand where they are. In all the scenarios that we talked about, it was often months before anyone knew that anything was wrong. But attackers are very predictable. The first thing that they're going to do once they're inside of something is try and persist their access or elevate their privileges. If you've got some session cookie that's keeping all your hopes and dream alive, once that goes, then you're shut out. So the first thing they're going to do is try and persist access. Honeypots are basically ways of saying, here's persisted access, here's credentials. that they will use, and perhaps even just through automated scanning, that will alert you immediately once they're in there. So, that's the first step. So that honeypots let you know. There's a bunch of different types of honeypots. There's honey tokens, which is what I used in there. The Git Guardian has a commercial version, but there's also open source ones. There's more, like GG Canary, and it's basically a Terraform script where you can just create credentials that are harmless, that will alert you. And then there's other types of honeypots. My favorite, I have nothing to do with it, is HoneyPY. And this is just basically an application that no one should be trying to use, but is very appealing to attackers. So honeypots are a great way, not of preventing an attack, but of understanding when it is in there, because then you can actually do something about it. This is a cool product that we just launched called SAS Sentinel. It's like Down Detector, but for breaches. So we've just deployed honey tokens and honeypots and all of these services that no one should be accessing, and if they get breached, then we'll publish it on here. So it's just a cool little side project that we're doing at the moment. The other one is managing secrets. You'll notice that a lot of the attacks involved secrets in some way, right? Maybe it was the initial access, such as the code cov example. Maybe it was how they persisted access or moved into different areas. But secrets, and secrets inside source code particularly, is a big problem. So how do we do this? So we need to scan our repositories for secrets. We can do things like use Git hooks to prevent them from getting in there in the first place. Please, please, please use secrets managers if you're not already, and then rotate your secrets regularly. So when you're picking a secrets manager, this is where I get a little bit controversial and I break away from the traditional security talk, is that there's lots of ways to manage secrets. So there's dedicated managers like Vault that we talked about. 1Password has one. There's a bunch more. These are just 3 random ones I picked. I think Vault's the best, but it's also the hardest to manage. You almost need a team just to manage Vault by itself. Then you've got your cloud managers. So if you're using a cloud provider, they'll have secrets managers. And then way down the bottom, you have encrypting your secrets and putting them inside places like Git repositories. So what is the best one to use? Well, the best one to use is Vault or anything else. And then it kind of goes down. But for me, the best one to use is whatever you're going to use. If you're a team of 5, you're not going to use Vault. Maybe you will, but it's very heavy. It requires a lot of work. 99% of all security people will tell you that encrypting your secrets and storing them in places like Git is a terrible idea. And I agree with them nearly always. It gives you a single point of failure. That encrypted file is going to sprawl everywhere and you're not going to be able to understand it. But where I differ is that if that's what it takes to stop sharing your bloody secrets in Slack messages, then do that. If that is what it will take. So once we're managing our secrets, implement scanning. There's a lot of open source tools. Obviously, I work for a Git Guardian, so whatever I say about Git Guardian, just assume it's wildly biased. But there's open source tools out there. Git Leaks, Yelp has one. GG Shield is an open source one by us. So there's no excuse not to scan your repositories and scan your infrastructure using open source tools, because at least that gets you moving. Now, maybe you'll need to move to a commercial scanner, but just get started. Understand where your secrets are and understand the problem, because there's plenty of free tools available to do that. Understanding your dependencies, software composition analysis, SCA. Again, lots of commercial tools. I don't really have a favorite of these. Sneak is probably the one that's used the most. There's obviously lots of open source dependencies, and then there's also tools that help you create a software bill of materials, or an SBOM. So these are really good for a number of reasons. One, where I talked about dependencies at the start, I talked that we have really little visibility over what our dependencies are dependent on, where they have. These tools can help us with that. They can also help you understanding when something is turned malicious and let you understand your risk. It helps you understand what you're affected to and where it could be. And for the SBOMs, it's great to have that list there of what you're actually dependent on. Now, the software bill of materials that are automatically generated are never going to be enough, but they're going to give you a start. And these basically help with compliance, and it helps you understand your risk and have strategies in place for when something is turned malicious, or at least found to be vulnerable. It's probably a more likely scenario when something's found to have a vulnerability in them. Have a process in place to be able to understand what to do from that point on. Some other things of adding it in there: zero trust. So whitelist services, sign requests so you know what they are, and reduce everything to the lowest privilege. If you need to pull some information from an Amazon S3 bucket, please do not create a credential that can do anything other than that. Reduce everything down to its limited scope. Whitelist services, so if something's only meant to talk to this machine, make it only be able to talk to that machine. Because that way, if you're a part of a software supply chain attack, then the attackers are going to have a lot of targets, and they're basically wanting to see how can they pivot and move into different areas quickly. If you can segment them, if you can contain them in an area that isn't vulnerable, then that is a win, because it's very hard to prevent them from getting in there in the first place. Segment your environments. Developers very rarely need access to production environments. I know some do. I know admins do. But in a lot of cases, we can have just developer environments. Tests don't need to be run in production. Please don't run anything. But also remember, development credentials are better than production credentials, but they're still sensitive, and they still could give opportunity to move into different areas. And then the last one is a mindset breach. A mindset change is just to assume you will be breached. So assume that it's going to happen, because it changes your mindset and starts thinking about things differently. Then you're thinking about, how can I prevent insider threats? How can I prevent privilege escalation? How can I prevent this stuff once something's inside? Because you notice I've been talking very little about how to prevent them going inside, because I don't think the solution is to put up so many barriers of walls that we can't do anything and we can't move forward quickly. We need to move forward quickly, but we can prevent damage once they're inside. And these are just more general thoughts of what can we do as an industry? Where can we move right now? I mean, I'm a big fan of moving away from secrets, dynamic secrets, ones that are used just in time, decentralized trust. I think we're getting a little bit better with some of the legislation that's come out of America that's requiring SBOMs. This is going to help, because when something like Log4j happens again, and it will, then we can actually everyone had a hell of a time trying to understand what was vulnerable. Infrastructure should be default to private. There's something that infuriates me, is that when you spin up something, one of the objectives of the cloud provider or the service that you're using is to make it as easy as possible so that you can move quickly. Get everything up running quickly with as little friction as possible, which means that it's probably going to be the defaults are going to be as insecure as possible. So it should be hard to make something insecure. And my example of this at the moment is Amazon S3 buckets. There's been some policy changes which make it harder to make them public. But a couple of years ago, every single day, there would be another Amazon S3 bucket that was discovered that was totally vulnerable, because that's just the default. Platforms need to normalize security. So MFA should be standard, and this is actually starting to happen. And security education should be a pillar, of developer training. A lot of this is actually happening. So I like to finish on this, because we are moving in the right direction. I know that supply chains can be a little bit depressing, but we are getting better as an industry and moving in the right direction. And I always just like to say we have more control than we actually probably realize. We can't control much of what our dependencies do, apart from choosing good dependencies, choosing good services. But we can control how much damage can be done if we change our mindset to it. And with that, thank you guys, and I'd be happy to take any questions. So thank you.